of the more APB.
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 Are you also struggling to learn APB? Then watch this complete video.
Welcome back to our channel. So today in this particular video we are going to understand the APB protocol in detail. See, in protocol wise APB is your basic protocol, so you have to understand it thoroughly. So today we are going to cover all the aspect which was there with APB protocol. So without further delay, let's start the video. So myself Kittu Patel, and if you have any query, so you can contact me on this number or you can drop a mail on this mail ID. So let's start the video. Now these are the content which are going to cover in this particular video. So first of all, why APB, why we are using APB, and then we have basics of APB, so we will see what is there with APB. Now after that we will see that what are the possible operating state which was there in APB, and finally we will see how the transfer has been done in APB. So these are the four fundamental topic which we are going to cover in particular video. Now introduction to AMBA APB protocol. So your APB stands for Advanced Peripheral Bus. It's in part of AMBA family which was developed by ARM. So ARM is an organization. ARM has provided us many protocols which comes under the category of AMBA, that is APB, AHB and AXI. All these three are on-chip protocol. So first of all, you can understand like what is mean by protocol and where protocol is used. So protocol is nothing but some predefined rule which you are going to follow when you are transferring your data. So let's say I have told you like I have one master and I have one slave. Now I have to transfer some data between master and slave. So I have to follow some approach, like I don't just pass all the data randomly. I have to follow some method. So that method is nothing but protocol. You get the idea about the protocol. Now your APB is a low bandwidth protocol. So it is supported by the low bandwidth peripheral. Peripheral means either it's your UART, GPIOs, all those are peripheral. Now APB is also known for its simplicity and low power consumption. So since it's a low bandwidth peripheral device, so it is also compatible with the low power. Okay, so it consumes low power, and also it deal for control register access in peripheral. Now your transfer initiated by bridge. So what is mean by that? So here your master is treated as a requester, whereas your peripheral interface is a completer. So see, whenever your transfer is initiated by the APB bridge, so it is act as a requester. It will request the data and pass it to the completer. Okay, so it will pass it to the another side. Now terminology, requester refers to the APB bridge, whereas your completer refer to the APB peripheral. I hope it is clear. Now here you can see that like we have considered multiple signal. We will see each signal in detail. Okay. Now here you can see like why we are using APB protocol. So suppose let's say here we have bridge. This bridge is nothing but your APB bridge. Now here in left of your bridge we have some high bandwidth device. But what if I have high bandwidth device and I have to establish a communication between high bandwidth to low peripheral device? So in between them we are using some bridge. So the role of this bridge is to low down the frequency so that other device, and you can say this slave, are compatible with the frequency of the data they are receiving. So that's why we are using that the APB bridge. Okay, I hope it is clear. So here in left side we have some high bandwidth device, and the data which are passing through this high bandwidth device are going through the APB bridge. So here we are lowering down the frequency, and then after we are sending it to some GPIOs and UART, which is low bandwidth peripheral device. So that's how your APB will come into the picture. Now what are the possible features, or you can say what are the features of APB protocol? So it has simple interface, like it is easy to interface, like it has very simple interface. Also it consume low power. We have seen why APB is consuming low power, and also it has low bandwidth because it is compatible with the low bandwidth peripherals. Now it has synchronous operation. So here like synchronous operation means like it depends on clock. So it is synchronized with the clock. Suppose we have some clock, so your all signal are synchronized with the pauses of clock. Now it is non-pipelining. what is non-pipelining? So see, like now later you come to know about the AHB and AXI. These both protocols are pipelined. So what is mean by the pipeline and non-pipeline? So in non-pipeline, before initiating the next transfer, your current transfer should be completed. So there is no something like if your address phase is going on and you can pass the data simultaneously. So this is not possible in APB, but in AHB or AXI this is pipeline behavior is possible. Okay, so let me explain you once, like let me explain you again about the pipelining. So suppose if you have initiated some transfer, so before the completion of the entire transfer you are not allowed to initiate the another transfer. I think it is okay. Okay, so here your APB is non-pipeline. So after the completion of your first transfer, then and only then you are allowed to start the second transfer. So that's your APB protocol. So it is non-pipelining. Now it is handshaking mechanism. So what is handshaking mechanism? So we will see in detail like whenever we are visiting the ready signal and all that. But handshaking mechanism means it is waiting for some like acknowledgement. If it is not getting the acknowledgement, so it will not transfer the data. So handshaking is nothing but we are waiting for certain acknowledgement. If we are receiving the acknowledgement, then we can proceed for the data transfer. So that is nothing but these are all the features of your APB protocol. Now after that we have low complexity and low power consumption. So why it is low complexity and low power consumption? So since like it is compatible with the low peripheral device, so since it is compatible with the low peripheral device, so it doesn't require more power like to operate. So here we have only two phases, that is setup phase and access phase. We will see each one in detail, but for being now you can consider here we have two phases. So whenever you are transferring some data, so your data will be travel, or you can say your data will pass through these two phases. Okay, so in first phases we are passing the address and control information. So in first phase we are passing the address and control information, whereas in second phase we are passing the data information. Okay, now it is non-pipelining. So I have explained you what is the meaning of non-pipeline. Now also it is single clock operation. So I have told you like it is a clock, like it is synchronized with the clock. So your entire signal, like all the signals of your APB is synchronized with your clock. Okay, now these are the signals which was present with APB. First of all we have P clock. So P clock, here your P terms is indicating nothing but peripheral. Okay, so here your P is indicating the peripheral. Now here P clock, so P clock is nothing but the clock that is synchronized with all of your signal. So here this clock is synchronized with all the signal. So your P clock is rising edge of P clock, time of all transfer on the APB. Now P reset, so here we have active low reset. Now P address, so P address means in which slave we are going to transfer the data. So that is nothing but address, or you can just remember it like this, like it which address we are going to transfer the data. Now we have P select. So see, like we can see in operating state part, like here P select signal is used to select the slave. So suppose let's say we have one master. So suppose we have one master and we have multiple slave. Okay, now here your master, like here your master is quite confused, like for which slave they are going to communicate. So let's say here your master want to establish a communication between your slave, but at a time it can establish a communication between only one slave. So here this master will select the appropriate slave by using S select signal. Okay, now here your in S select, X is indicating that which slave has been considered. So suppose if you have P select 0, so let's say your 0th slave, that means this slave has been selected. If your P select is 1, so this slave has been selected, and that's on. Okay, I hope तुम लोगों को समझ आ रहा होगा. So यार समझ लेना, और अगर कुछ भी प्रॉब्लम हो तो कमेंट्स में लिख देना, ठीक है, फॉर द हिंदी ऑडियंस. So after that we have P enable. So P enable is nothing but if your P select is asserted. Okay, so just keep this in mind. If your P select is asserted, so on the next cycle it is mandatory that your P enable should be high. So just keep this in mind. Suppose let's say here your P select signal is asserted. Let's suppose this is your clock and here your P select signal is asserted. So on the next cycle it is mandatory for your P enable signal to be high. Okay, so that's you should keep in your mind. Now after that we have like P ready signal. So P ready signal is driven by your slave. So suppose let's say we have one master इस साइड होता है ना, हाँ चलो, वी हैव वन मास्टर एंड वी हैव वन स्लेव. मास्टर छोटा नहीं हो गया क्या? ठीक है चलो. सो वी हैव वन मास्टर हियर एंड वी हैव वन स्लेव हियर. नाउ this ready signal has been sent by the slave that it indicate now slave is ready for the transfer. So let's suppose master has sent the address and control information, but master have to wait until slave gives the P ready signal to the master. If slave assert the P ready signal, so that means slave is ready, so master can complete their transfer. So that's the role of P ready signal. And this is also a handshaking signal, so just keep this in mind. Now after that we have PR data. So PR data is nothing but the data which you are reading from the slave. So there are two main type of data, that is PW data and PR data. So we have mainly two type of data, that is PW data and PR data. So PW data is indicating that the data which we want to transfer from master into the slave. Okay, so PW data is nothing but we are transferring some data into the slave from master, but PR data is we are reading some data from the slave into master. So this is PW data and this is PR data. Okay, now after that we have P slave error. So P slave error will like if you suppose see when P slave error will be there. So suppose if you are trying to access something that is not there in the slave, like suppose your slave is of your slave contain 16-bit location, or you can say like the depth of your memory of slave is 16, but I am accessing the 17th address location. In that case we can get the slave error. And there are many reasons also for the slave error, like if you are trying to read something from the write only memory and if you are trying to write something in read only memory. So that are all the possible cases with the slave error where your slave error will be high. Okay, now this is very important, very 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 वो हमको करवाते थे ना जब 10th में अपने थे कि most. So you can here add up to 10 m and then IMP. Okay, so this is most important in APB protocol. So see, like this is the operating state of APB protocol. So first of all we are like we was there in idle state. Let me change the color of my marker. Yeah, so first of all we are in idle state. So just keep this in mind. In idle state your P select signal is 0 and your P enable signal is 0. Okay, so in idle state your P select signal and P enable signal is 0. Now in order to reach to the setup phase we have to make our P select signal to high. Okay, so in order to reach to the setup phase, so this is your setup phase. So in order to go to the setup phase we have to make P select signal to the high. Now here also our P enable signal is low. Now we are in setup phase. Okay, so in setup phase we are configuring our address and control information. Just keep this in mind. Okay, so in setup phase we are configuring our address and control information, not the data information. Okay, we are not configuring our data here, or you can say here we are configuring. So in setup phase we are configuring our address and control information. So what is this address and control information? So your P address, P write, PW data, that all we are configuring in setup phase. After the setup phase, in the next clock cycle we are making our P enable signal to high, or we are toggling our P enable signal to high. So here your P select signal is high, here your P select signal is high and P enable signal is also high. So here you can reach in enable phase, or you can say access phase. Okay, so in access phase your P select signal and P enable signal both are high, but here you can see some transition. So what is this transition indicating? So if your P ready is 0, like your slave assert the P ready like your slave is not asserting the P ready. So that means right now your slave is busy, or either it is not collecting the data or response which you are sending. So in that case you have to wait, and when you are in wait state, you doesn't allow to change anything, any control information or address information which you have set. Okay, so in wait state, like whenever your P ready is 0, in P select and P enable signal, whenever your P select and P enable signal is high and P ready signal is 0, so that state is known as wait state. So in wait state you have to keep this in mind, like you are not gonna to change any address and control information. If you are doing so it is protocol violation, और उसमें तो हम भी कुछ ना कर सकते. ठीक है, तो ऐसा मत करना, भूल कर भी मत करना. So that's all. Okay, now suppose like if P ready has been asserted, so P ready, after the assertion of P ready, it is like possible that you can reach to the setup phase, or it is also possible to reach to the idle phase. So in which case we are going to setup phase, and in which case we are going to idle phase. So suppose let's say you have multiple transfer, and right now you have completed only one transfer, so you can again go to the setup phase by deasserting your P enable. Okay, but if you have completed your all transfer, so you can deassert both of your P select and P enable and go to move back to the idle phase. Okay, so I hope it is clear. See, like operating state is very useful, so if you haven't got anything, like if you have any doubt, so you can just go back and watch it again. Okay, because this is very helpful. मेरे को कोई वॉच टाइम नहीं चाहिए यार तुमसे, तो इसीलिए ऐसा मत सोचना कि मुझे वॉच टाइम चाहिए तो मैं पीछे भेज रहा हूँ. लाइक दिस इज वेरी यूजफुल. ओके, सो जस्ट गो थ्रू इट. नाउ आफ्टर दैट these are all the signal which we have. Okay, so now see, like P clock is an input port. So suppose, let me show you with some diagram only. Here I don't have any space. So see, like P reset and P select signal is, P reset and P clock signal is our global signal. So these two are global signal. So here it is input from master. Okay, now PW data. So here see, like PW data, suppose this is your master, this is your slave. Now here we are passing PW data from master to slave. Okay, so the transfer in this way. So here PW data is outing from the master and incoming in the slave. So here PW data is output port for the master. Here we are discussing about the port. Okay, so here PW data is output for your master and input for your slave. See, like just keep this in mind. If arrow is something like this, so here it is outing something, so it will become output port. And in here, like here some component are there, so here for this component it is incoming, so for this it is input port. Okay, now PR data. So PR data direction is something like this. Here it is coming from the slave, so here it is coming from the slave. For slave it is the output port, for master it is the input port, and here we have written all the port with respect to your master. Okay, now after that we have P select signal. So P select signal should be sent by the master, because master has to select the slave, which slave they want to, from which slave, at which slave they want to establish a communication. So that should be selected by your master. Now after that we have P enable signal. So P enable signal is also asserted by the master. So for master it is an output port, and for the slave it is an input port, and similarly like this all your port are there. Okay, now this is very important. After operating state, this is very important. Now here you can see write transfer with no wait state. Okay, so here we have write transfer with no wait state. So we have seen in operating state part. So first of all, like no wait state means our P ready is asserted whenever your P select signal and P enable signal is high. At that time we have P ready also high. So that means we have no wait state. We are not waiting for the transfer. Okay, now here you can see at T0 to T1 we are in idle phase, because our P select signal is low here. So we are in idle phase. Okay, now for T1 to T2, here our P select signal is rising. Here you can see our P select signal is asserting. So here we are in setup phase. Now in setup phase you can see we have loaded our all control and data information. So here we have loaded our P address, then P write, then P enable is low because we are in setup phase, so P enable is low. Now we have also loaded our data. Now in next phase we are enabling our signal. See, P enable is high and we are moving to the access phase. So T2 to T3, here we have access phase. Now here in access phase, see, P select signal is high, P enable signal is high, and P ready signal is also high. So for this phase only our data should be transferred to the slave. Okay, so we can say that like here there is no wait state, but in second waveform here you can see here we have wait state because here we have make our P ready signal to 0. Like see, here our P enable signal is 1, P select signal is 1, but our P ready signal is 0. So here your data or control information have to wait until your slave assert a P ready. So here P ready is asserting by your slave. So here your data transfer will be completed. Okay, so this is how you can just go through this waveform. Now similar for the read, and like it is quite similar that we have like the things which we have seen in write, the same thing with the read also. Okay, so I am not taking much time. Okay, so signal ports of APB protocol. So P slave error. So I have like explained this part, like why P slave error. So P slave error is nothing but if you have like access some memory location which was not there in your peripheral, so it will give a slave error. And like if you are trying to read something from the write only memory, so it will also give you a slave error, and in vice versa case are also possible, like if you are reading from write only memory and if you are writing in read only memory. So that's all the cases which was the reason or which was the primary reason for your slave error. Then APB protocol violation. Now protocol violation, they see like there are many cases where your protocol will be violate, वो कभी भी violate हो जाता है, but like you have to take care. Like suppose see, if you have asserted P select signal, now in next cycle if you are not asserting your P enable signal, so this is considered under the protocol violation. Okay, this case is protocol violation. Like if you have selected the P select signal and if you have asserted the P select signal and in next cycle you are not asserting your P enable signal, so this is protocol violation. Or you can say you are like in setup phase and again you are moving back to the idle phase by keeping P select signal to low by deasserting your P select signal, so this will also considered under the protocol violation category. Now the conclusion is, यार ये पढ़ लेना यार, मैं ये क्या पढ़ूँ मैंने ही लिखा है so पढ़ लेना. So that's a wrap. Now you know APB always present and brilliant. भाई ये जो भी जिसने भी प्रेजेंटेशन बनाया है ना यार, बहुत बढ़िया बनाया है. किसने बनाया है? ओहो, ये तो मेरा ही नाम है. So thank you guys. So if you found this video useful, so just give a like and also subscribe to our channel. Okay, we are going to upload AXI and AHB also in this channel, so just subscribe कर लो यार. Thank you.